Good morning to everyone. My name is Madhavi. My roll number is 234 G1A0466 ECE branch. My topic is voltage and current relation with the phasor diagram. Subject name is BEEE. This is outline for my topic voltage and current relationship with phasor diagrams in C circuits. Introduction. Phasor diagrams are graphical representation used to analyze the relationship between voltage and current in AC circuits. In AC circuits, voltage and current vary with time. Phasor diagrams will help us understand the amplitude, phase and frequency of voltage and current in the circuits. This is a phasor diagram of a waveform. Definition of phasors. Phasors are rotating vectors that represent the amplitude and phase of sinusoidal quantities. In a phasor diagram, the length of the vector represents the amplitude of the quantity and the angle represents the phase. Phasor rotate at a constant speed, which corresponds to the frequency of the AC signal. This is phasor diagram of sinusoidal waveform. Voltage and current phasors. In a phasor diagram, the voltage and current phasors are represented as vectors. The voltage phasor represents the amplitude and phase of the voltage in the circuit. The current phasor represents the amplitude and phase of the current flowing through the circuit. And this is phasor diagram of sinusoidal waveform. This represents Vm, Im, Vm plus, Im plus. This is the angle phi. This is the angle 30 degrees between reference axis and lagging axis. Relationship between voltage and current. The angle between the voltage and current phasors represents the phase difference between voltage and current in the circuit. If the voltage and current are in phase, the angle between their phasors will be 0. If the voltage and currents are out of the phase, the angle between their phasors will be non-zero. Current and voltage phases in pure R, C and L circuits. Current in the sum anywhere in a single branch, including phases of voltage in series components are reference to the current phasor. Apply sinusoidal current T is equals to Im cos omega t. For pure R, L or C loads, phase angles for voltage drops are 0, pi by 2 minus pi by 2. Reactance means ratio of peak voltage to peak current. These are representation for voltage and current relationship. Impedance. What is meant by impedance? Impedance is a complex quantity that represents the opposition to the flow of current in an AC circuit. In a phasor diagram, impedance is represented as a vector. The magnitude of the impedance vector represents the magnitude of the opposition to current flow, and the angle represents the phase shift between voltage and current. This is the graph. Here ZL is equals to RL plus J omega L, polar form. ZL is equals to modulus ZL e power j phi. Phi is equals to tan inverse omega L by RL. This is RC circuit. ZC is equals to RC minus I by omega C. ZC is equals to modulus ZC e power j phi. Modulus JC is equals to root of RC square plus minus 1 by omega C whole power square. Phi is equals to tan inverse minus 1 omega C RC. Ohm's law in phasor form. Ohm's law in phasor form states that the phasor voltage across a component is equal to the product of the phasor current and the impedance of the component. Mathematically, V is equals to I. Z, where V is the voltage phasor, I is the current phasor and Z is the impedance. This shows Ohm's law. V voltage, R resistance. V measured by voltage measured by volts. I is impedance. I is current measured by amperes. R is resistance measured by ohms. P measures watts. P means power. We can measure current, voltage, power and resistance by Ohm's law. Series AC circuits. In a series AC circuits, the phasor representing voltage and the current are aligned along a single line. The sum of the voltage phasors across each component in the circuit is equal to the sum of the current phasors flowing through the each component. Phasor diagrams help us analyze the voltage and current distribution in a series AC circuit. This is AC circuits, this is graphs, this is equations for series AC circuits, and this is a parallel AC circuits. In a parallel AC circuits, the voltage phasors across each component are equal. While the current phasors flowing through each component may vary, the sum of the current phasors entering a junction in the circuit is equal to the sum of current phasors leaving the junction. Phasor diagrams help us analyze the voltage and current distribution in a parallel AC circuits. What is AC circuits? For this circuit diagram, we can understand what is AC circuits. This is circuit globe. Power in AC circuits. In AC circuits, power is a complex quantity that includes both real and reactive power components. The real power represents the average power consumed or delivered by the circuit, while the reactive power represents the power exchanged between the circuit and the reactive elements. Phasor diagrams can be used to calculate the real and reactive power in AC circuits. Conclusion. Phasor diagrams are powerful tools for analyzing the relationship between the voltage and current in AC circuits. They help us to understand the phase difference, impedance and power distribution in the circuit. By using phasor diagrams, engineers can design and complex AC circuits efficiently. Thank you for listening my words.